So, quick introduction. My name is Yun Bin. So, I'm from Sembcorp Industries. I'm actually working in the digital function of Sembcorp Industries. We are a global energy player. And the reason why you see two logos over here is because last year at COP27, we launched a corporate venture called GoNetZero, where we aim to be a one-stop carbon management platform solutions for a lot of our clients. All right, a quick show and tell. So, over here, this is our track record. So we are an energy provider solution. The stats here are outdated, but we manage around 18.5 gigawatt of assets globally, out of which 11 are renewable energy assets. Yeah, so as you can see here, we have solar, we have India spanning across multiple countries. And of course, more relevant to today's conversation is actually the data portion, which is on a day-to-day basis, we actually manage around 600 million data points from our sites globally. All right, so for today, I'm actually here to talk about one aspect of our whole technological stack, which is we're actually using blockchain technology to help with many of our back office processes, to speed up the back office work and also to create extended applications that are useful to our customers. So over here, our blockchain tech stack, we actually use an open source blockchain by Linux Foundation. So we are using both the Hyperledger Fabric and Hyperledger Besu. And more importantly for today's conversation, it's more towards Hyperledger Besu, where we actually, backed by Ethereum, machine, we actually tokenize a lot of our energy data. And the reason why we are using a enterprise level blockchain is because, of course, energy data, yes, a high throughput. Every day we process like millions and millions of data points, and we think that, using an enterprise blockchain is actually very scalable, and of course, the privacy issue and the security issues. All right, so here is a portfolio of what we developed for many of our solutions in Sembcorp Industries. So in the digital function, we have many operating systems from the Wind OS, Solar OS, Battery OS, Water OS, and Hydrogen OS. So today's topic, I'm actually going to talk about three things. Number one is proof of renewable energy generation, which many of our customers are actually coming to us and asking for it, demanding for it. How can we prove that the energy coming from your asset is truly renewable? And of course, next we have the Battery OS. So we have actually the largest battery fleets in the UK and in the Southeast Asia, totaling up to approximately 700 megawatt hour of capacity. And upcoming in our pipeline, we are actually looking at importing green hydrogen. And following, so I'm from Singapore, so following Singapore's energy policy, we aim to have 50% of our energy powered by green hydrogen, low carbon hydrogen, by 2050. And of course, all this data, we are actually aiming to push it on-chain so that all our customers can have access to it. Yeah. So very easy and intuitive view over here. Very, very similar to the TCP/IP 7 layers protocol. The first layer is actually all our physical assets. So in all our physical assets, as we are the energy provider, we actually have IoT data attached to all of them. They stream in near real time to our data servers, and then we process it. So most of the data goes on the blockchain layer. And after that, we have our optimization layers running on it. And of course, ultimately, there's the presentation layer where our customers can access it. All right, so number one, proof of generation. So this use case actually came in last year. And we actually have clients coming up to us, amid various greenwashing backdrops and everything. And they ask us to prove how exactly is green energy generation truly green, you see. So, and it's this case where, we actually met with Energy Tech, we worked with Energy Tech, and then we aim to pilot something in Southeast Asia itself. So as you can see here, what we do is that at our generation sites, we do a 30 minutes tokenization. So, and why we tokenize it is, of course, we want to prove. So means every 30 minutes, coming from a unique solar generation site, for example, in that specific 30 minutes time block, we generate a semi-fungible token so that we can actually, and this token is actually transferred to the customer's address on the chain so that they can actually see their energy being credited to them almost in near real time. And the many applications that extend out of it, of course, is number one, and very relevant over the past few talks, is 24/7 carbon-free energy. And we see this as a value add because, we have data centers coming to us. We have clients who are data centers. And last year, we actually piloted a use case of 24/7 matching in Singapore with UBS, where we actually match their office buildings consumption load according to solar site that they're actually purchasing from. And of course, the next two applications, back office EAC registry integration. So as I think Killian mentioned just now, is that most energy provider companies, they actually have a hard time dealing with EAC registries. So what we do is actually the same data payload that is used to create the tokens on chain, we send that same data payload via APIs. In Singapore's case, it's to IREC. And in IREC last year, they actually launched the standards and APIs to create the granular certification itself. So this is a simple infographic of how we actually piloted with UBS last year. So it's quite simple actually. The customer provide us with their consumption data. They are in a long-term REX purchase agreement at a generation site. We tokenize the generation data, we match it according to their consumption, and we calculate the carbon-free energy score for them. All right, so then here comes the problem, because in Singapore, the main renewable energy is from solar energy. So for companies to truly reach 24/7, it's actually quite difficult, almost impossible for nighttime consumption. So that's where, number one, either load shifting optimization comes into play, or we actually look at battery storages itself. So what we are developing with our battery storage in Southeast Asia, we have approximately 285 megawatt hour of battery storage used for ancillary services. And this is what we're actually going to do. So we will continue using our optimization algorithms, to do energy arbitraging, to do frequency regulation with the grid itself. But at the same time, we are also experimenting, allocating battery space for customers who want to achieve, a higher carbon-free energy score on an hourly basis. So what we do, standard day-ahead generation forecast, we do our local optimization. We provide the day-ahead charge and discharge schedule. And in this case, we will do the energy tokenization, and after which, I'll show you guys a bit of what we are actually developing. All right, so this is basically what I mentioned just now. And something that we are actually doing right now is how are we marrying, our machine learning algorithms, our AI algorithms with the blockchain itself, and both technologies should actually speak to each other. And we're actually using blockchain as an accountability system to track the optimization results and show it to our customers that, we are actually using the correct parameters, we are using the correct forecasted data, so rest assured that there's no data tampering involved in the process. So this is something that we are actually looking at as well. So the use case for this is that, of course, as I mentioned, Singapore, solar energy, right? So how do we actually match someone who is buying solar energy to their consumption at night? And the only way we can do that in Singapore is through battery storage. So very easy, we have all these are implemented on a smart contract layer in the blockchain. So we create different tokens. So one token is the generation token, after which is the charging tokens, and after which is the discharging tokens. And there's a relationship between all three different tokens, and we call it a token burn cascade. To mint one, you have to burn the other. So, and all these are captured on the ledger, where customers can access it in real time. So basically, long story short, we take away the whole black box. We allow customers to really see and show, how much green energy is being charged and discharged by the batteries itself. Okay, and of course, another thing is a VPP assistant that we are developing as well. We have several VPPAs, and actually in many VPPAs that we have in Singapore itself, it's a contract for difference at a 30 minutes interval. So it's actually very apt for our use case. So as you see, in a VPPA, we have to settle the price difference for every 30 minutes. And For example, if like Amazon buys from us, for example, in a VPPA with this solar generation site, and they want to actually prove that, you know, I'm paying this much for this amount of energy being generated, pegged to the national energy market price. But there are some data which is actually sensitive. So what we are doing is we are actually doing zero-knowledge proofs. This is one aspect of a cryptographic element in blockchain itself, where we can actually prove certain data in the whole equation without actually showing the data itself. And of course, there is automated settlements where we integrate with bank APIs. So when one party pays the other, it automatically triggers the release of the tokens on-chain from one party to another. Yep, so everything can be tracked almost in real time. Yep, and lastly, as I mentioned, we are also in the green hydrogen business. In Singapore itself, we have plants that are going to be commissioned by 2026 by Sembcorp Industries, where we actually can, you know, burn the green hydrogen that we import from other countries. And one thing about green hydrogen is we actually have to prove that it's using green energy for the electrolyzers itself. Yep, so we are working with a few Japanese companies. And of course, you know, we do the same use case. We tokenize the generation data, and then we packed it to the consumption from the electrolyzers. So that's one aspect. And the other aspect that we are also experimenting on is the whole supply chain portion. When, you know, we import this ammonia, what are the greenhouse gases being discharged in the process, how we can track it via sensors, via IoTs, etc. Yep, so that's the end of my presentation. So over here, that's the website, that's our LinkedIn page. So we can just follow if you guys are interested. And of course, if you want to talk more about the technology itself, please feel free to reach out to me. All right, thank you. No questions, right? Oh, yes. Oh, so great question, actually. So that's the reason why we chose an enterprise-level blockchain in the first place. So actually, most of our sites itself, we are onboarding them on-chain. We stream the data. When it hits our server, it hits the smart contract on the blockchain as well, and then we immediately tokenize the energy generation data itself. But we are selectively doing it for some sites as of now, because for us, there's no point in tokenizing everything, except for sites that actually have extended use case. And one example is UBS, for example. Last year, they wanted to track and peg their generation to their consumption, so that's why we are doing that. Yeah. Oh, yes.
I don't know much about blockchain, but do you use proof of work or proof of stake?
Oh, so the Hyperledger base, so we actually use a proof of authority. We call it IBFT 2.0. Yeah, Istanbul Byzantine Fault Tolerance Consensus Algorithm. So proof of work belongs to the Bitcoin blockchain, so we don't use that. Yeah. Yes. Yeah, so very good question, actually. So this question is actually not just towards the customer's consumption profile, but also the generation profile as well. So our own generation profile, we have our own algorithms in check, you know, to make sure, you know, there are plausibility checks and possibility checks for each generation site. If my solar generation site is, for example, 6 megawatt peak, there's no way in 1 hour it can generate, like, you know, taking into account the efficiency and everything, there's no way that site can generate, let's say, 5 or even 6 itself. Yeah, so these are the layers of checks we have in our algorithm. As for the customer side, we actually just provide them an API, or some customers don't even have APIs already, so they actually provide us in Excel files. And of course, we do the whole validation check according to their historical consumption all the way back, a few years back, yeah. Yes. Okay, so you're talking about, let's say, the economies of scale of like,
No,
understand?
this like proof of I get green electricity. It's great, but for like the climate, it only works if there's more green electricity.
Oh yes, yeah. So
Otherwise, it's just everybody else gets what's left anyways.
yeah, that's very true. So just to add on to that comment itself, I think RECs, carbon credits, those are the last line, right? But at the start, what we should aim is to actually reduce the consumption or even like optimize the consumption itself. So that's where we have the load optimization, how we can effectively increase, let's say, your PV production, etc., etc. Yeah. So RECs, carbon credits, those are at the downstream of the whole value chain. But I think, yeah, as you said, what we should focus on is actually on the upstream itself. Yeah.
So if I understand correctly, you're using the blockchain to offer essentially transparency service to your customers. My question is, can you offer equivalent transparency service also without blockchain?
Oh yes, definitely. So end of the day, data is data, correct? So we can actually, push the data onto, let's say, a simple dashboard and show it to our customers. But the reason why we choose to do the blockchain level is, of course, the immutability of the data itself. Let's say if I push it on a dashboard, I can actually go in and change, the numbers in my database, and the customers can actually have no trace of that changing. But as of if we do it on a blockchain, every single change actually there shouldn't even be a change in the data, but any change in actions or anything on change will actually be recorded as another block and another block and another block. So everything is actually immutable and it's a ledger, so everything is recorded. Yeah.
But is it also possible to build an immutable ledger simply on your servers without using a blockchain? For example, by including hashes which refer to history of previous transactions. So I'm just challenging the use of the blockchain.
Oh yes.
We can take this offline.
Okay, sure. All right. Thank you.